Have you ever gazed up at a jumbo jet soaring through the air and wondered, how does that massive thing even stay up there? It's a question that has captivated humans for centuries. The answer, my friends, lies in the incredible world of science and engineering. We call this fascinating field aeronautics. It's the magic behind how airplanes conquer gravity and take to the skies. We're going on an adventure to uncover the secrets of flight. We'll explore the forces that make it possible, and the ingenious design features that let these metal birds soar. Fasten your seatbelts, and get ready for takeoff. To understand how airplanes fly, we need to dive into the world of aerodynamics. This fascinating field of study helps us grasp the principles that allow these massive machines to soar through the skies with grace and precision. Aerodynamics is the study of how air, a fluid, moves around objects. By observing these interactions, scientists and engineers can design more efficient and effective aircraft. It's all about the flow, the forces, and the fascinating interactions between air and things moving through it. The way air flows over and under the wings, the shape of the aircraft, and even the speed at which it travels, all play crucial roles. When it comes to airplanes, there are 4 key players we need to meet: lift, weight, thrust, and drag. Each of these forces has a unique role in the flight process, working together to keep the airplane in the air and moving in the desired direction. Lift is the upward force that counteracts gravity, making it possible for the plane to climb and stay aloft. This force is generated by the wings as they slice through the air, creating a pressure difference that lifts the plane. Weight, as you might have guessed, is the force of gravity pulling the airplane down toward the center of the Earth. It's a constant force that must be balanced by lift for the airplane to maintain altitude. Thrust is the force that propels the airplane forward, generated by those powerful engines. This forward motion is essential for generating lift and overcoming drag. Lastly, we have drag, a force that acts like air resistance, trying to slow the airplane down. Managing drag is crucial for efficient flight as it directly impacts fuel consumption and overall performance. Now that we've met the forces at play, it's time to dive deeper into the fascinating world of airplanes. These incredible machines are marvels of engineering, designed to conquer the skies with precision and grace. Let's take a closer look at the star of the show, the airplane itself. From the tip of its nose to the end of its tail, every part plays a crucial role in making flight possible. Just like a bird has wings, a body, and a tail, airplanes have specialized parts that work together to achieve flight. Each component is meticulously designed to perform specific functions, ensuring the aircraft can soar through the air with ease. The wings are the true heroes of lift generation. They are the primary structures that allow the airplane to rise off the ground and stay aloft. They have a special curved shape called an airfoil. This design is not arbitrary, it's the result of years of aerodynamic research and testing. This shape, along with the angle at which the wing meets the oncoming air, we call this the angle of attack, creates a difference in air pressure. This difference is what makes flight possible. The air flowing over the top of the wing has to travel farther and faster, creating an area of lower pressure compared to the air flowing underneath. This pressure difference is crucial for generating lift. This pressure difference generates lift. Without it, airplanes wouldn't be able to leave the ground. We can't forget the fuselage. This is the main body of the airplane, and it serves multiple purposes. That's the main body of the airplane where you and all the luggage hang out. It's designed to be spacious and comfortable for passengers while also being strong enough to withstand the forces of flight. It's designed to be as streamlined as possible to minimize drag and improve fuel efficiency. The smoother the fuselage, the less resistance the airplane faces as it moves through the air. Then we have the tail section, which acts like the airplane's steering system. It's essential for maintaining stability and control during flight. It has horizontal and vertical stabilizers that help control the plane's pitch, up and down movement, and yaw, side-to-side movement. These components ensure the airplane can navigate smoothly and respond to the pilot's commands. Finally, there are the engines, which provide the mighty thrust needed to propel the airplane forward. These powerful machines are the heart of the airplane, converting fuel into the energy required for flight. Modern jet engines are marvels of technology, capable of producing immense power while being efficient and reliable. They are meticulously maintained to ensure safety and performance. Together, all these components work in harmony to make flight possible. The next time you board an airplane, take a moment to appreciate the incredible engineering that allows us to soar through the skies. Designing an airplane is no easy feat. It takes a team of brilliant minds, including aerospace engineers, to bring those flying machines to life. It all starts with an idea, a vision of what the airplane should be able to do, how far it needs to fly, and how much it can carry. Once the basic concept is in place, engineers get to work using sophisticated computer software to create detailed designs. They consider every little detail, from the shape of the wings to the materials used to build the plane. Safety is always the top priority. Engineers run countless simulations and tests to ensure the airplane can withstand the stresses and strains of flight. Section 5: Computational Fluid Dynamics, Simulating the Invisible. Imagine being able to see how air flows around an airplane without even building a physical model. That's the power of computational fluid dynamics, or CFD for short. CFD is a powerful tool that allows engineers to simulate the invisible world of aerodynamics. Using complex mathematical equations and powerful computers, CFD programs can predict how air will behave as it flows over the surfaces of an airplane. This helps engineers optimize the design to improve lift, reduce drag, and enhance fuel efficiency. It's like having a virtual wind tunnel at your fingertips. Section 6: Wind Tunnel Testing, Putting Designs to the Test. While computer simulations are incredibly valuable, there's nothing quite like putting a real airplane design to the test. That's where wind tunnels come in. Wind tunnels are giant tubes with powerful fans that create controlled airflow. Engineers use them to test scale models of airplanes and see how they perform under different conditions. By carefully measuring the forces acting on the model as it sits in the wind tunnel, engineers can validate their designs and make any necessary adjustments. They can even simulate different weather conditions like rain, snow, or turbulence, to ensure the airplane can handle anything Mother Nature throws its way. Section 7: Winglets and Sharklets, Outsmarting Drag. Have you ever noticed those little wingtips sticking up at the ends of some airplane wings? Those, my friends, are called winglets, and they're a fantastic example of how clever engineering can make airplanes even more efficient. Winglets work by reducing drag, that pesky force that tries to slow the airplane down. They do this by disrupting wingtip vortices, which are little swirls of air that form at the wingtips. By smoothing out the airflow, winglets help the airplane slip through the air more easily, saving fuel and reducing emissions. It's a win-win. You might also hear the term sharklets. These are just a specific type of winglet with a more curved shape like a shark's fin. Section 8: Composite Materials, Lighter and Stronger. Just like athletes need lightweight gear to perform their best, airplanes benefit from being as light as possible. That's where composite materials come in. Composite materials like carbon fiber reinforced polymers are made by combining different materials to create something entirely new with enhanced properties. These materials are incredibly strong and stiff, yet much lighter than traditional aluminum. This allows engineers to build airplanes that are not only more fuel efficient but also more durable and resistant to fatigue. Section 9: Biomimicry, Learning from Nature's Flight. Nature has been perfecting the art of flight for millions of years, so it's no surprise that engineers often look to the animal kingdom for inspiration. Birds, insects, and even bats have evolved incredibly efficient ways to navigate the skies, each with unique adaptations that allow them to soar, hover, and glide with ease. By studying these natural flyers, engineers can uncover secrets that have been refined over eons. This practice of imitating nature's designs is called biomimicry, and it's revolutionizing the way we design airplanes. Biomimicry isn't just about copying nature. It's about understanding the principles behind natural designs and applying them in innovative ways. This approach has led to breakthroughs in aerodynamics, materials science, and even propulsion systems. For example, the shape of winglets was inspired by the wingtips of soaring birds, which have evolved to reduce drag and improve efficiency. These small, upward curved extensions at the tips of airplane wings help to minimize the vortices that form as air flows over the wings, reducing turbulence and saving fuel. This simple yet effective design tweak has had a significant impact on the aviation industry. Some engineers are even exploring the use of morphing wings, inspired by birds that can change the shape of their wings in flight to optimize their performance for different conditions. These morphing wings could allow airplanes to adapt to various phases of flight, such as takeoff, cruising, and landing, making them more versatile and efficient. Imagine an airplane that can adjust its wing shape in real time, just like a bird. It's amazing what we can learn from nature. The possibilities are endless when we open our minds to the lessons that the natural world has to offer. From the intricate flight patterns of birds to the silent glide of an owl, each observation can lead to a new innovation in aviation technology. Well, there you have it, explorers. We've delved into the fascinating world of biomimicry and how it influences modern airplane design. By looking to nature, we not only find inspiration but also solutions to some of the most complex engineering challenges. We've journeyed through the fascinating world of aerodynamics, airplane design, and the incredible innovations that make modern air travel possible. From the sleek, aerodynamic shapes inspired by birds, to the advanced materials that mimic the strength and flexibility of natural structures, the impact of biomimicry is profound. From the principles of lift and drag to the ingenious use of winglets and composite materials, it's a testament to human ingenuity and our endless fascination with the skies. The next time you see an airplane, remember that its design is a blend of human creativity and the timeless wisdom of nature. So next time you board an airplane, take a moment to appreciate the science that makes it all possible. Happy travels, and remember, the sky's the limit when we learn from nature.